All right, class. So the first video dealt with what was considered a random sample. And now we're going to talk about the word inference. Okay. So an inference is just basically, it's a conclusion based off of calculation, statistics, data, right? If you have the data of who likes certain things, what type of chocolate chip or what type of cookie they like, then you can make an inference about the whole population, right? That's the whole point of a survey, really, class, is when I survey 100 people, I want to make an inference about the population. There's no way I'm actually going to survey the entire population because that would be too hard. That would be very difficult, almost impossible, right? So that's exactly what a survey does, right? Survey gives us a easy way to make a judgment about the population without actually finding the data from every single person. Okay, so below is the data collected from two random samples of 100 students regarding students' cookie preference. Uh, Make at least two inferences. Okay, so I think there's a clear winner in terms of the flavor of cookie, and the first inference I would make is chocolate chip is the favorite flavor, is the most preferred flavor. Um, okay, and then is there another inference? You could also say like, wow, chocolate chip is so overwhelmingly large that chocolate chip is more popular than, than oatmeal and sugar combined, right? You could also say something like oatmeal and sugar are pretty similar in their preference. My favorite would be, it's a hard one. I think sugar is pretty good. Chocolate chip is obviously good too. Um, okay. And sometimes people make incorrect inferences. So we definitely need to practice our ability to use judgment and our ability to read statements and to see if they actually line up with the data, right? So the data from two random samples of students regarding their favorite sports to play are given below. Okay, student sample one, you can see, wow, football and basketball. I agree with that. I really like these two sports. Soccer is third, and track is fourth. And the data is pretty close, right? It's pretty similar to the first sample and the second sample. So let's go ahead and read these, and let's just see if they are true or false. And these are just inferences, right? Basketball and football are more popular than soccer and track. Okay, now remember, this is just a survey of a particular area. This is not really a survey of the world. We don't know what the survey of European countries are. Maybe this is just a survey of Pacific Trails, right? Pacific Trails Middle School. But this we would say is true. Um, let's say track is twice as popular as basketball. Is track twice as popular as basketball? Unfortunately, that's false. Approximately 30% of students prefer to play basketball. Well, let's say this is about 100 and 63 out of 100. Well, yeah, that's 63 out of, actually, sorry, 200, which is approximately 30%. So this is true. Football is about 1.5 times more popular than soccer. 1.5? True. Track is the most popular sport. False. Football is more popular than basketball. Okay, so this is really interesting because football, is it more popular than basketball? Maybe slightly, but it is so close that actually this would be a false statement because it's too close to call, right? They're basically even. Now, I know in math class, you're like, wait a minute, 49 is not the same as 51. Well, in surveys, when they're so close like that, you have to realize that because the survey is already in estimation, 49 and 51 to me into surveys are basically the same. Okay. A sample is biased if groups of the population are not represented, right? If I want to survey what your favorite chocolate chip cookie is, or what your favorite cookie is, and I only survey the math A students of my class, and then I make a conclusion about the whole school. Well, the problem is I've only surveyed my students, and they didn't survey the entire school, right? Another one is like a very, very bad example is like if I surveyed and wanted to figure out what your favorite cookie preference was, and I only surveyed the boys of my class. Well, you would not get a representation from the girls. That would be a terrible way to survey things. You want to make sure that you're not openly omitting certain groups. You want to make sure the entire population is represented. Okay. A sample is representative if the sample truly and fully represents the population. If I only surveyed the honors students of the school, well, then you would say, wait, what about all of us, like everyone else, right? You can't just survey a certain group because that wouldn't be representative. Okay, so let's go ahead and practice more examples of what we consider is a random sample or not. Okay, so some of these will be funny, hopefully. The nutrition department wants to know the school lunch preferences of the K through 12 students, K through 12 meaning kindergarten all the way to 12th grade. And they want to know this nutrition, they want to know the lunch preferences, so they survey the 100 kindergartners. What? The kindergartners would just want milk and cereal and cookies, right? Like kindergartners are adorable, but that would not be a good sample, right? So this is, I'm just going to call it not representative. Not representative. What is the average amount of time Horizon Middle School students spend watching TV? Ask every 10th student exiting the school. Ask every 10th student exiting the school. I would say that's pretty good. This is random, right? Because you're not really deciding. You're not going to the lunchroom. You're not going to Mr. Kuo's class. You're going to the outside of the gate, and you're randomly sampling the 10th student that you see leaving the school campus. I think that's pretty good. The principal wants to know the favorite movies of the 7th grade class of 450 students. She randomly selects 3 names from grade 7 pages of the yearbook and asks those students. Okay, so this is debatable. This to me is random, but there is a slight problem, right? The sample is not big enough. And we learned that the law of large numbers is important. So just randomly selecting 3 people is not large enough, right? That's not a good enough because you need more data. Predict the winner of the state election for governor. Survey 80 randomly selected 10th grade students. 10th grade students, and you're talking about the winner for an election. This is not random. This is not good. 10th grade students can't even vote. Right? So you have to understand the context matters. You can't just ask kids or high school students or preschool students about an election because now all of a sudden your pool is not even effective at all. It's not does not fit the context. Okay. How long on average does it take 7th grade students to complete their English homework? Ask all the English teachers. Wait a minute. You want to know how much time it takes to finish the homework, and you ask the teachers? Not the best choice, representation. I would just say that, right? Sometimes the teachers, I mean, they should know, but not the best representation, right? So it's not random. What proportion of the eighth grade at your school chooses basketball as their favorite sport? Ask everyone on the soccer team. What? This is not random. And in other words, it is very biased, right? So hopefully this lesson today, class, helped you realize the difference between something that is random, something that is biased. Whenever you are doing a survey, you want to make sure that you include an unbiased way to collect data. Okay? And that concludes 7.1C lesson. Thanks for watching.